What's going on, ladies and gentlemen? Thank you so much for tuning in. It's me, Mikey Pipes. Heading to my first service call of the day. We have a existing client. This is the first time we're going there for their air conditioning. This is going to be a maintenance visit only for the outdoor units. I have a method to my madness. Unless there's a need, we alternate every other year with indoor-outdoor. Let's go over to Atlantic Beach and enjoy the ride. We got two Lennox systems here and a Mr. Slim. Let's check out our coils. Looking pretty okay. Let's get the tools and start working on them. All right, ladies and gentlemen, just got a quick little overview of the inside of the house. We have those two thermostats that are controlling these two systems. Customers lived here for a couple of years. Last summer was his first summer in the home. Overall, the installation, from what I see, is okay. We have these two outdoor condensing units going inside. The slim duct cover, they got a little creative there with the use of the Flex line set cover right there. That stuff that's up there probably was existing, but overall, proper distancing, okay, good. But our coils, we're starting to see some age, and it's definitely weathered. Why they don't make these stickers UV resistant is beyond me. All right, let's start with taking these things apart and see what they're doing. All right, so I'm going to try to run this by you guys step by step. I'm going to do both at the same time. When I take my covers off, the cover on the left is for the unit on the left, the cover for the right is for the unit on the right. We're going to just do a visual inspection of the components. We do have a fair amount of just some rust and corrosion on top of our dual capacitor. Terminals on the contact are not looking too healthy either. A little bit of just dust inside the electrical compartment on the one on the left and identical to the one on the right. That little wire resting right there, it should be right there like that. That could cause a short. The vibration of the compressor rubbing that wire across the terminals, that's no good, so we'll want to take a look at that, make sure we tighten that up a little bit. Contactor looks a little bit better on the unit on the right. Interesting, since it's closer to the ocean. Filter dryers, looking okay, no rust or corrosion on anything right there. Let's work next by pulling power. Now you're going to take the left hand behind your back, okay, and you can use your right hand and not touching any metal. Take your fingers, pull out the disconnect, okay. Now the reason for doing this is when your left hand is behind your back like this, if there is an electrical short, you're using your right hand. This is where your heart is. If there is an electrical short and what you're about to disconnect, right, the electricity is going to travel through your right hand, down the side of your body to the ground. And I say don't touch anything metal, because if any part of your body is touching metal, you could have some serious consequences. We're going to do the same thing with the other condenser, with the other disconnect, sorry. We're going to pull that power out, and then we're going to test component by component the components of these two outdoor units. All right, before proceeding, we're going to make sure we have no power here. We're going to test our incoming power, and there's no power there. Let's do the other one. Same there as well. See? And sorry, it's upside down. And now line to ground, and then the other line to ground. You see, no power there. Back to this one. There's our ground. The line right there. See that? and the other one also no power. Now both systems we verified with a known good voltmeter that electrically both are disconnected. Now it is safe to proceed. We're going to discharge our capacitors. I'm just going to take a needle nose and we're going to touch the top of the terminals together like that on both. We'll do the same thing with the other one like that. Best to discharge these. All right, don't use your fingers and don't get zapped. All right, I removed that one screw that was holding on the capacitor band with a 1/4-inch driver right there. And I'm making note of our terminals. The yellow wire is on that 3-pronged terminal. That's for our compressor. The purple wire is on our 2-pronged terminal, and that's for our fan. And the red wire, that's on the 4-pronged terminal, and that is for our common or C. Let's remove these wires and let's test this capacitor with our voltmeter. All right, I'm going to set my meter to read capacitance. For this test, I'm using the Fluke 902FC. Highly recommend this one for any HVAC technician out there. And we're going to go from our common to our fan. And we're going to have a lot of rust there. We're not reading anything. Let's see if we can get a better contact there. All right, I use my alligator clamp probe adapters to go into my leads. And I got 5.1 on the fan. Let's take off the fan side and let's test our hermetically sealed or HERM, and we're getting 45.2. So this capacitor is test fine. However, and she passed the shake test. So regardless of what it technically looks like, it passed and it's tested fine. Next, I'm going to remove the low voltage control wires going onto our contactor. Okay. This is a 24 volt signal, right? That is coming from our thermostat. And that's what turns on our unit. As soon as this contactor gets 24 volts on that 24 volt coil, that power is going to pull in the contact point, on this case a single pole contactor, and send power from L1, L2 to T1, T2. So now with our voltmeter, stay there buddy, with our voltmeter set to read resistance, we're going to take one test lead on one side and the other test lead on the other. All right, and we get 18.3 and we're good. Anything in the teens, resistance is good on your contactor coil. All right, off camera, I tested the capacitance of the dual capacitor on the other unit, and she tested fine. I also tested the coil resistance on the contactor, and that also tested in the 18 range. Next, let's get rid of this debris and dust that's accumulating inside of our electrical compartments. I like to use a leaf blower. Here I'm using the Milwaukee compact leaf blower, and just give everything a good blowout. Give her a good blow job, if you know what I mean. Okay, get all in there. And I have a nice rubber tip, as you can see here. There's a nice rubber tip, so I could get in there and touch things without fear of disturbing anything and breaking anything. All right, both electrical compartments are now clean. I paid a little extra attention to the top of this contactor. Had some debris there. Other one also as well. I'm not really too worried about like caked on dirt in there. I just want to get rid of any cobwebs, dirt, leaves, just things that really shouldn't be here. Get that out of the way. And also blew out at the bottom where the service ports are. All right, so I'm done with the electrical components. In my experience, I've been easily able to remove condenser fan motors from the top of their condensing units without having to disconnect any wiring, because we need to take off the top in order to clean and rinse the coil. But before I put my covers back on, I'm going to take a picture of the charging information, the charging charts, and the electrical schematics that are on the inside covers, and attach that to the House Call Pro property profile for here. That way we can always reference it again in the future. And it's also in case we need to charge or check our charge at the conclusion of the service call. We don't have to take the cover back off and double check by looking at the label. All right, so now that both electrical compartment covers are on, I'm going to remove all the screws holding the condenser fan motor to the top of the condensing unit. And we're going to take a look on the inside of the coil, check our bottom of our condenser fan motor, and do the cleaning process of the coil. And yes, I stopped for a moment to take a selfie, video selfie, to share with you guys. Let me show you what's going on inside these units. All right, ladies and gentlemen, this is what you have to deal with when you live near the ocean. Like literally, I kid you not. The coil is just flaking apart. Literally just flaking apart. And we're at the beginning stages of deterioration here. And unfortunately, I really need to clean these because the amount of dirt and just salt that's covering these coils really interfering with heat transfer. So it is what it is. We're going to try to find the hose, source of water, and we're going to rinse these. Before doing so, we're making note of the bottom of our condenser fan motors, also making reference of the size and speed. There's no oil residue there, so they're both intact, as you can see. So we're just going to give these a good rinse and hope for the best. All right, gave them a good rinse with water, inside and outside. I got to put all the screws back in, and I just had the homeowner turn on the first floor system just so I can hear which contactor is pulling in, and I can mark that, and for future reference, good for service to know. All right, next step, we're going to check the amperage draw of each unit. Now, I'm not checking at the actual electrical compartment itself. I'm checking overall the incoming power, right? As long as my amperage is within range, I don't need to like dig into each one individually. You know what I mean? So we want to save time, but also do a diligent job at the same time. So we're going to use those same techniques and using our right hand, right, to reinsert the disconnect plug with our left hand behind our back. I have my Fluke 902 FC voltmeter set to read max. Let's plug this bad boy in. Nothing. Our contactor, which was previously calling for cooling and pulled in, is now off. All right. Gotta love those Nest thermostats. Okay, heard that pull in, all right? Remember, very impressive. A max of 58.3 amps were pulled. And right now we're running at 7.6, 7.8, 7.9. That number may climb as the condensing coil warms up. Right now it had that cold water going across it when we rinsed it with the water. Now, one thing to notice, I did not show it on video, or that much on video. Maybe I did, but very little pressure, right? You don't want like a pointy stream where you're going to start eating into the coil, and you know, it's no good. We're defeating the purpose of what we're trying to do. 7.7. Very nice. We're going to let this run for a little while, let the system stabilize, and then we can check our refrigerant pressures. All right, let this stabilize and run for a little bit. My amperage did not increase. I pulled the disconnect. That way I can properly reassemble the disconnect panel, the internal panel, and that way I can close her up. I did take the liberty and used a Sharpie on the inside to mark that first floor. I also took a label maker and marked that first floor. Eventually that's probably going to fade off, but you can still see that inside. I want to direct your attention, ladies and gentlemen, to the other disconnect, the one that I marked for the second floor, which is going to this second floor condenser. I want you to take a look at what's wrong here. We have two leads of power, right, on one lug, and this is wrong. And what I guess is happening here is that they brought in one line of power and they're feeding both condensers off one circuit. It's quite obvious that's what's going on here. Whoever installed this Mitsubishi Mr. Slim, apparently this is on its own separate circuit. I could be wrong, but that's not good. You don't want to have one circuit for two systems. I get it, you know, for temporary measures, you need to steal power for whatever reason, you know, as temporary measures only. I'm not endorsing it or supporting that method, but if you need to do something temporarily, great, while an electrician can come or someone can come and run, you know, a qualified individual can come and run that dedicated circuit for that unit. So what we got going on here is wrong. It should not be it should not be done permanently like it is here. I'm gonna guess our incoming power is coming in right here, and they jump it to the other unit right there. So our incoming power is right there, and look at how they even did that. That's just, let me clear that away a little bit. That's just wrong. You have that metal possibly rubbing on that. Oh man. You know what? I guess they don't care. It's not their home. You know, if the house burns down, oh well, right? No, but that's not good, and we're gonna let the homeowner know. All right, the next and final step of this service call is we're gonna test refrigerant. Now, I don't normally recommend that you test the refrigerant levels and pressures and temperatures during a regular maintenance service call. However, since the customer does have some cooling complaints on the inside of the home with certain rooms with with southern exposure, there's the Atlantic Ocean about 1,000 feet right there. I want to check them, make sure they're good. We'll see what happens. We know that we have a TXV system, so we're going to check for subcooling. Now, the first line of defense on any leak is your service port caps, right? Your service port caps are the first line of defense against refrigerant leaks, right? They protect, well, let's not lose that. They protect the Schrader core valves, right, from any potential leaks. And there are those little things right there in the center of your screen. They're identical to the your car tires, right? Same little thing, same little principle. Those Schrader cores or valves stop the pressure from leaking out and allow us to add, you know, pressure or check pressure. So I have my Testo 557 zeroed out. All of my valves on this 4-port manifold are closed. We're going to take our low pressure hose and we're going to hook it up to our low side, which is generally in cooling. That's that larger pipe. Okay, I'm using yellow jacket hoses with these special low loss fittings, right? These fittings are designed to not let all of the refrigerant in the hose escape when they're taken off. All right, my refrigeration hoses are connected to my service ports. I also use the Testo wireless clamp-on temperature probes to read my suction and my discharge pressures. And that will allow my Testo 557 to give me some more numbers that I would like to see. The actual temperature of those pipes, the suction and the discharge line, that will give me a calculation for superheat and subcooling. Subcooling on the bottom right-hand corner of the screen, which is indicated of that SC, and we're reading 1.3 with an outdoor ambient temperature right now of 57 degrees. It's a little tough to say. What I could do to duplicate a warmer day, I could cover up the top of the unit a little bit and see if these pressures increase. Now, they also do make special hoods that are like this, basically, it's a big giant, like a little tent, inflatable tent that straps onto here, and then it helps restrict the airflow at the top of the condensing unit to duplicate warmer operating conditions. And as you can see, my temperatures are slightly increasing. We're at 2 degrees of subcooling and slowly climbing. We're gonna let that stabilize for about 5 minutes and see what our temperatures and pressures are like. All right, ladies and gentlemen, it's been about 5 minutes. Still sitting just under 3 degrees of subcooling. We are slightly undercharged here. We're going to have to add a little bit of refrigerant. So let me show you that process. All right, guys. I got a container here of 410A. Used to be in pink containers. Now the jugs are this, I don't know, pewter. Actually, it does look like pewter, like American Whale McLean Indirects, right? Pewter. My low loss hose is connected on top. My manifold's all still off on my 4-port gauge. We're going to open up this refrigerant right here, and I am going to bleed out the air by opening up this for a couple seconds, and then I'm also going to bleed out the air in my low and high side hoses. Okay, and that as well. Now, the reason for doing that is because if I do not purge out or bleed the air, or what we call non-condensables, from these hoses, as I introduce new virgin 410A refrigerant into this system, those non-condensables are also going to be introduced into the system, and that is no bueno. We don't want that. We want to limit any non-condensables, like oxygen, that's in the air, H2O, or O2, I don't know, whatever, into the system, because you don't want that in the refrigeration circuit. That refrigeration circuit is the condensing unit, the compressor, the suction and liquid lines, right? Our metering device, and our evaporator coil. That is all part, those 4 components are all part of our refrigeration circuit. Obviously, the line set is not technically part of the refrigeration circuit, one of those 4 items, but it's part of the system. All right, now we're gonna flip this jug upside down, and I'm gonna make sure my scale is zeroed out, and then we're gonna add a 1/2 pound refrigerant. Okay, she's at 0. We're gonna open up the charging port and open up our our low pressure hose port. And we're gonna go to right to 1/2 pound of pressure. 1/2 pound of liquid refrigerant. That's 0.3, 0.4, and 0.5. Okay? And we're going to let this stabilize for about 5 minutes. And we're going to watch our pressures. Hopefully they don't go crazy. It happens. It happened to me many times. You add, a 1/2 pound of refrigerant, all of a sudden it goes wonky, and, you have extremely high head pressure. On the liquid side, 600 psi, and things going crazy, and you're panicking, right? So just 1/2 pound at a time, and you'll be good. Generally, if something happens, obviously there was something going on in the system. Maybe a piece of dirt was in the hoses, you introduced it, and then it clogged up the metering device. Shit happens. What can I say? All right, ladies and gentlemen, we are at 1.92 pounds of R410A. My subcooling is a little 9.5 degrees. I'm quite content with that, being that I have a restriction on the top of my condenser fan motor. 2 pounds is not great to be adding to a system. Factory charge was 6 pounds, 11 ounces. I don't know. I don't know if it was ever properly charged to begin with. Some contractors just, we'll just open those service valves and dump the charge and have a nice day. But I do know that the one on the left, this is that sticker from it, because it's protected from the sun, not like that one right there, being exposed to that southern sun. This 3-ton condensing unit needed 2 pounds. So that'll be a wrap for this one. We're going to proceed on to the next and finish up the service call. All right, both sets of service caps on both condensing units are nice and tight. Remember, ladies and gentlemen, those caps are the first line of defense against any refrigerant leaks. For branding purposes, I got my company sticker right there. Identify the name, our logo, phone number, and website. Speaking of website, if you're in the Long Island, New York City metropolitan area, Queens, Nassau County, Suffolk County, not so much of Suffolk County, and you would like a professional service call by Pipe Doctor Home Services, head on over to pipedoc.net. Click on the link at the bottom of the screen to book an appointment online. Select the relevant chip charge for either plumbing or HVAC. For plumbing, we generally only service Nassau County and a little bit of Queens, but HVAC services are available as far north as Westchester County, White Plains, and the Bronx, Brooklyn, and parts of Suffolk, with a separate trip charge that's different than our typical 115 trip charge. Thank you so much for watching. I'd really appreciate any thoughts, feedback, even criticism down in the comment section down below. Let me know if I did something wrong. I'm only human. We only make mistakes, but we learn from our mistakes, which makes us grow. And I honestly believe that together we can make the trades great again. Let's get the youth graduating school into the trades, because guys like me, we're slowly dying off. Catch you in the next one. Be well, God bless, stay safe.